Hey guys, what's going on? It's been a while. Yeah, so I tried. I really tried. In the last video, I made this simulation of a BLDC motor and I could control it with AI. So in this video, I wanted to control a real motor. And why didn't any of you guys stop me? This was way too hard. I mean, it kind of works. Yeah, that's not really the result I was expecting. But I learned a lot, so that's pretty cool, right? Hey, stop. No, do not hit the back button. I did not spend over a month slaving over a hot circuit, nearly spending $1,000 just for you to go and click the back button. Okay, we have a lot to learn about electrical circuits, testing things with oscilloscopes, a little more Q learning, even some neural networks at the end. So just get nice and comfortable. There we go. Okay, see, that's much better. All right, perfect. Okay, so this is the real world. We have a real motor, and so we're going to need a circuit to control it. For the brains of the circuit, I went with something called a teensy 4.0. It's a microcontroller, which is basically a small computer. And by the way, my friend suggested this to me. He's pretty cool. He's got tricopters, he's got balancing robots, he's into his own brushless DC motors. It's a hot trend, I'm telling you. He even has one going nice and smoothly, so I linked his channel down below. I recommend to check it out. But yeah, I went with the teensy for the brains. We're trying to control this motor, and if I power the motor directly from the teensy is going to blow up. And that's because it just can't supply enough current. So the motor has very low internal resistance, and at the teensy's 3.3 volts, it would draw 16.5 amps, which would just blow the board up. So we need a circuit in between these to drive the motor. Okay, motor drivers, what do we got here? We got the L6234 three-phase motor driver. That sounds good. It's a triple half bridge to drive a brushless DC motor. Psh, perfect. What else we got? What else? Oh, of course. We have the DRV8313RHHR. This thing is another triple half bridge driver. Let's see here. Three-phase brushless DC motor. Psh, man, I'm on fire. Surrounded by all these great options. So cheap, so available, so easy. Wait, I have it. I'm going to make my own circuit. That is genius. That is not a waste of time. And no, it's not an excuse to go buy a bunch of stuff on Amazon. So let's go buy all this stuff. All right, everybody relax. Let's just jump right into this driver circuit already. Come on. All right, so here's a finished part of the circuit. And at the end of this, you're going to understand every little part of this in excruciating detail. All right, so we start with the teensy and the motor, and we bring in a battery to power the motor. And we can connect the motor all sorts of ways to the battery. And by doing this, we're energizing different coils in the motor. So this is just like in the last video when I had my power supply, and I'm connecting high and low voltage to the inputs of the motor, and you can kind of see it jumps around when we do that. So if we do that in the right order, we can make the motor spin. So that's what our circuit needs to do. Now this drawing of a battery is exquisitely beautiful, but let's introduce some symbols here. The triangle means 5 volts, and the little 3 lines means 0 volts or ground. So I'm going to use those throughout the diagram like this, which means I've connected the top input of the motor to 5 volts and the middle one to ground. Now the simplest way I can think of connecting these to high or low voltages is just using 2 switches. So if we connect the top switch, then that's going to connect our input to 5 volts. And if we connect the bottom switch, that's going to connect our input to 0 volts or ground. But of course, we want current to flow through this, so let's just copy our switch circuit and connect our second input of our motor. And now, if we connect that switch and that one, then current will flow from 5 volts into the motor, back out, and down to ground. So we have a complete circuit. And this will actually cause the motor to jump. We can also connect this switch, and now current will flow in the other direction into the motor through the top wire, out, and to ground. So you can see we've kind of changed the direction of the current through these top 2 wires, and I'll just flip back and forth here. So if we had a third set of switches connected to the third input, we basically could control the current in the motor however we wanted. But of course, we don't want to use physical switches, and this second set of switches is basically a copy of the first. So let's just focus on the first set of switches and figure out how we can control this with voltage from the teensy. And like most of life's problems, the answer can be solved by buying stuff on Amazon. So here we have some voltage controlled switches. So you can see you get 10 for $8, which is actually a terrible deal, but I need the 2-day shipping. Damn you, Amazon. The diagram in the circuit looks like this. They have 3 pins called the gate, drain, and source. And there are actually 2 different types, P channel and N channel. With the P channel, we usually draw the source up top and then the drain, and the N channel has the drain and then the source. And the P channel also has a little dot on the gate. So let's connect these to our teensy and draw some scary looking formulas, but they're really simple actually. Basically, for the P channel, you can see when the voltage difference between the source and the gate is above some threshold voltage, the P channel will be on, or like a closed switch. And for the N channel, when the voltage from the gate to source is above the threshold, then it will be on. And otherwise, both will be off and not conducting, like open switches. Now, I only wanted to use one output from the teensy to control both of these, so I connect their gates together. Now let's do a little demo. So if I put 0 volts on the gates, then you can see VSG is 5 minus 0, which is 5 volts, so the P channel is on. And then VGS is 0 minus 0 volts, so the N channel is off. And so we've effectively connected our motor to 5 volts. Now we reset. If we put 5 volts on the input, VSG is 5 minus 5, which is 0, so that's not above the threshold. The P channel is off. And then VGS is 5 volts, so the N channel is on. We've effectively connected the motor to 0 volts. And if we just step back and look at the simplified circuits, we can see that at 0 volts in, we get 5 volts out, and 5 volts in, we get 0 volts out. So we've kind of made like an inverter circuit here. Now the issue is that this circuit takes 5 volts, but the teensy can only provide 3.3 volts. So we have to be a little tricky again and use one more switch. So by default, we connect the gates to 5 volts through this resistor. And now no current flows through these gates, so no voltage is dropped across the resistor, so they're effectively seeing 5 volts here. But if we use a little switch, we can connect them to ground, and so then all the voltage will be dropped across that resistor, and they will see 0 volts. So again, we have a switch that we need to control. Do I hear a problem? Amazon to the rescue. So we have another type of switch here. This one is a current controlled switch. You get 200 for $5.80. I don't know if that's a good deal, but I needed the 2-day shipping. God. Okay, anyways, so this is the diagram for it in the circuit. The 3 inputs are called the base, collector, and emitter now. And when a small current flows from the base to the emitter, a large current is allowed to flow from the collector to the emitter. So if we connect this to our teensy with a resistor to limit the current, and we make one of the pins high, or 3.3 volts on the teensy, a small current flows, and this basically looks like a closed switch to the circuit. And that has electrically connected our gates to ground, and so they see 0 volts. And then our inverter inverts that to 5 volts, and so that's great. And if no current flows, because we make the teensy have 0 volts on its pin, then this looks like an open switch. And so our gates now are connected to 5 volts. And so our inverter shows 0 volts at the motor. Okay, let it out. We did it. All right, so this is our basic building block for our circuit. It's cool because we can control it with the teensy, but it can drive a lot of current for the motor. But of course, this only takes care of one input of the motor, so we're going to need to make 2 more copies of this, and then we'll take each output from the teensy and wire it into each one and make those all go out to the motor. Oh yeah, if you want to make this yourself, you should be aware of something called flyback voltages. So this is a circuit with a battery, a switch, and an inductor. The inductor is a coil of wire. And basically, if I close a switch, a current will start to flow in this circuit. And the inductor really doesn't want that current to stop. So if I try to open the switch, it's going to make a massive voltage across it and cause a spark possibly to fly through there. Now, if that's one of our MOSFETs, it could blow it up over time and just break it. So we don't want that to happen, so we connect something called a diode across the inductor here, and now when we open the switch, the current has a place to flow. Now the diode is another type of electrical component, and it just allows the current to flow in one direction. So now our switch is happy. I think the MOSFETs have diodes built in. Someone could clarify that for me. So I never ended up using them in my circuit, but I thought you should know so you don't blow your stuff up. Okay, so how does current flow in our circuit? If we put 3.3 volts on one of the pins of the teensy and 0 volts here, then we'll get 5 volts on this pin of the motor and 0 volts here. And you can see the current is flowing from 5 volts from the battery into the motor, out this other pin, and then down to ground. So it's flowing through our MOSFETs and the battery, not the teensy. Whoa, we did it! You did it! I'm so proud. Oh my God. Yeah, I hereby award you the GNN Academy YouTube.com Electrical Engineer Certificate. You're Cat 1, 2, and 3 certified. You can work with high voltages, install some new wires in a building, and all for just 88 payments of $999.99.99. Guys, I have to buy better rope on Amazon.